All right, hello everybody, and welcome to the new and improved homework videos where we are only doing some of the problems, and that means everything will be in one convenient video. Super exciting. So let's get started because my intros are never that cool anyway. So we'll start with the first one. So this is using circle method. If you weren't here because of the field trip, or if you just didn't get to the last page of the notes, if you're looking at your guided notes or the guided note video, this is the last thing that we talked about during the laws of logs and exponents lesson. So if what I'm doing right now doesn't make sense, please be sure to go back and watch that one. But we are using circle method. So we're converting from logarithmic to exponential form, which means we just need to rewrite this logarithm as an exponent. So we use circle method. It looks like this. So we would say 6 squared equals 36, which is true. You could plug that in your calculator. It will literally tell you true. This just means, like, this is how you solve logarithms. This is what it means when we're doing logarithms. I feel like it can be easy to lose track of that. But this is literally saying, so 6 squared is 36. So if you see log base 6, 36, you know that's going to equal 2 because we need to make this statement true. Again, it's probably explained better in the homework video, so watch if you're not so sure about circle method. These two you guys can do on your own. So looking here, we have to go from exponential to logarithmic form. So this again is circle method. Honestly, I think exponential makes a lot more sense. So I always think about it in terms of exponential. So I'm going to start and just work from left to right. So I know if I'm writing in logarithmic form, I'm going to need a log. So I have log base 12. My next number, according to circle method, is 144 equals, what am I left with? 2. And that's how you write it. How I double check is if I look and do circle method the other way, 12 squared is 144. So I know I wrote it correctly. Once again, the guided notes video, for those of you who are on the field trip, that might be really helpful if this is all confusing, but it's pretty straightforward, right? You're just using circle method in different ways in both cases. Lastly, we're going to move into this section. So we're condensing each expression into a single logarithm. This means we're using our logarithm rules that we found when we did the activity. So I'm going to do this one, and this one if you're fast forwarding the video and just want a little guideline for where we're going. So without further ado, let's get started. This is the subtraction property of logarithms. So this means that we're going to divide our arguments. Once again, I think having your notes would be really helpful for this one. But this is going to end up being log of 3 over 8, like that. I put it in parentheses because now that we're starting to move into solving equations, we are taking the logarithm of 3 over 8. So it's just kind of important that we know that the log corresponds to 3 over 8, but no big deal if you don't want to do that. Moving on to this one, this is a 3-parter. So this is using the addition property. I'm going to pretend that says property. That means that we multiply our arguments. So I'm going to have, remember we need to check to make sure our base is the same, which it is. So I have log base 4 of 5 times x plus log base 4y. So I have a log base 4 of 5x plus log base 4y. I once again would want to multiply those. So I have log base 4 of 5xy as my final answer of 5xy. You might ask, why did I not just do 5 times x times y? I could have. I like to break it up bit by bit because then even if my sign switches, hint, hint, in the next one, I'm still just taking it 1 at a time or 2 at a time, and then it doesn't get as confusing. Good. Last one we want to do is this middle one at the bottom. So we have 2 log 5 to the x plus log base 5, 3. So the first thing you always want to look for is making sure that if you see a coefficient in front of your log that you swing that to be an exponent. So I'm going to start with that. So I have log base 5 of x squared plus log base 5 to the 3rd. Why is it important that we do that first before adding? Well, 2 reasons. One, I kind of think of it, it's not like terms, right? If there's a coefficient in front of it, it's 2 log as opposed to just a log. But also, if we think about order of operations, right, it makes sense to do multiplication or exponents, right, before we would do the addition. So we just want to make sure we take care of that too before we start. So then I'm left with this, which is the addition property like we talked about. So it's log base 5 times 3x squared. Because we're adding the logarithms, which means I'm multiplying my arguments. We're going to let you guys solve the ACT problems on your own, just because I think it's good as we get closer and closer to when you guys actually take the ACT to build some practice on that. So without further ado, let's flip to the back side. Here, it's a lot more clear which problems I'm going to do, so I'm not going to label it. This is what we did on, let me look at the calendar, Friday and Monday. So if you're A days, again, your homework's due on the 6th, and B days, it's due on the 7th. But let's look through this question. So Martha makes an investment of $500 in an account that pays 6% interest compounded monthly. So we see up here the formula for continuous interest. Is this continuous? No, because it does not say the word continuous. It says monthly. So I know I'm going to need this formula right here. A of t equals, oh my gosh, P times 1 plus R over N to the NT, because it's being compounded monthly. So let me label what I know. P is the amount I put down at the beginning. P equals 500. R is my interest rate, which is 6%. If we convert 6% to a decimal, right, I have to move it 2 to the left, so we are left with 0.06. And it looks like that's all. Oh, and my N is going to be, since it's compounded monthly, how many months are in a year? 12. So we are going to do 12. So how much money will she have after 2 years? So that means I'm going to be solving for A, because I want to know how much money she will have. So I have 500 times 1 plus R, which is 0.06, divided by 12, because that's N, times, or to the power of 12 times T. So we didn't know T from the front, but here we see it says after 2 years. That's my T. So it's going to be 12 times 2. I'm going to pop that in my calculator. Hopefully you guys can see it. Probably not, though, because my luck is never that good. All right, let's see. So I have 500 times 1 plus 0.06 over 12 to the power of 12 times 2, which is 24. So I'm just going to put 24 because I don't trust myself to type more numbers. And we're left with $563.58, which is also what I got when I wasn't talking out loud, so that's a good sign. $563.58. Next question says, write an equation for her interest earned if her interest rate changes to 5%. So that means that my P is going to stay the same. My R is different. Now it's 5%, so we're going to write 0.05. And my N is still monthly because it did not tell us that the rate we are compounding changed. Good. So if I was going to set up this equation, it would be 500 times 1 plus 0.05 over 12 to the power of 12 times T. Good. Again, if this was going to be compounded continuously, we would want to use this formula up here, right? But it just says interest earned if our interest rate changes to 5%, so we're going to assume that it's still keeping what we were talking about in our setup. Moving on to condensing the natural logs. So I know we haven't done this explicitly yet, but once again, natural log, which is represented here as ln, is just log base e. So it's the same logarithm rule. So it shouldn't be that much of a stretch to move from our logarithm rules into our natural log rules. So I'm just going to get started here. And if you have any questions, please come talk to me or Miss Avra. But let's bring this down. So we have natural log of 5 plus, I'm going to swing that coefficient into an exponent because that's the multiplicative property of logarithm. So we have plus ln to the 3 squared. So that's natural log of 5 plus natural log of 9, which equals natural log of 45, because this is the addition property of logarithms, which means we're multiplying our arguments. Next one, we have natural log of 4 plus natural log of 1/2 to the second power. So we have natural log of 4 plus natural log of what's 1/2 times 1/2. 1/2 times 1/2 is 1/4. So here, we once again have the addition property of logarithms. That means we're going to multiply my arguments. So we have the natural log of 4 times 1/4. The numerator will cancel with the denominator. We are left with the natural log of 1. Last one. This is the subtraction property of logarithms. I have the natural log of 7 minus the natural log of 14. So I have the natural log of 7 over 14, which is because I'm dividing my arguments with a subtraction property. Natural log of 7 over 14 is natural log of 1 over 2, if I'm simplifying. Once again, just kidding. This one, 51, we're going to let you do this one on your own. We're going to do number 52 together because it's kind of hard to read. So if b is a positive number such that this is log base b. So that's a b right there. So such that log base b, 1 over 81 equals -4, then b equals what? So this is another example of when circle method is actually really helpful. So we have b to the -4th power equals 1 over 81. So there are two ways to do this. Yeah, there's basically two ways to do this. I think the easiest way would probably be to just sit there with your calculator and try different ones and say, okay, so 3 to the -4th is 1 over 81. So actually my multiple choice answer strategy worked out pretty well for me because it's answer choice F. It's 3 is 1 over 81. So if that is enough for you, please feel free to stop watching the video because you could just check our different answer choices and substitute them in for B. There's two other ways I like to think about it. If we were algebraically trying to get out of here, if that's something that you would be interested in learning, how you cancel out an exponent is you would multiply it by its, what is the word? By its, reciprocal. Thank you, Miss Abra. Multiply it by its reciprocal because you're trying to make the exponent equal 1, so you get b by itself. So we'd have b equals 1 over 81 to the -1/4. And so if I took my answer, that is not what I meant to do. You could plug it into your calculator basically. So let's do 1 over 81 to the -1/4 power. It would give me 3, which is my answer. So that's another way to do it. Once again, if you have any questions, please feel free to talk to me or Miss Avera. But other than that, we'll see you guys next week.